So what we did this morning is we set up a static label switch path. Okay, so we set up a path going from PE1 to PE2, and then another path coming back the other way from PE2 over to PE1. And what we discovered is then we were able to ping from CE1-1 to CE1-2, and that the traffic between those two CEs went via our static label switch path. We also discovered that it was the BGP protocol that directed the traffic into the label switch path. And so BGP does play an integral part in the whole MPLS process. So the next thing we're going to do is we're going to take a look at setting up a label switch path excuse me, using label distribution protocols, or what is often referred to as signaling protocols. We're going to take a look at RTP and LDP. So the first thing we do is we have to, according to our labs at least, we have to go back and restore our devices, VMX1, VMX2, restore them to the baseline configuration. So basically, if you have a look at the labs, after you restore to the baseline configuration, the very next thing that you do is you go ahead and then configure the export policy on your CEs and apply that export policy. So you're then exporting the loopback address direct route into BGP, which you've already done, but the baseline sort of takes you back before that point, so you have to do it again. And you also have to then go and create the next hop self policy and apply that, which again we've already done, and you kind of have to do it over again once you go back to your baseline. So what I did is I actually created a kind of like another baseline, so I created another like save the configuration right after the next hop self was created and right before the label switch path was created. So what I'm going to do is I'm going to actually go back to that. So you're quite welcome to take that approach as well if you like, and just go back to that step. If we go back to it, I created that in pod 13, which is where I am. I created this NHS config, which is just what the name I gave it. So that is the config right before you create the static LSP. Okay, which is kind of, if you go back to that, it kind of saves you repeating those two steps over again. Right, so a little bit of work and save there. So I'm going to go back to that. The other approach you can take, if you don't want to go back to that, or if you forgot to make or save the protocol at that point, you could actually just disable your static path and kind of go from there. So I'll just show you what I mean by that. I'm just going to show that there. There's our static path. So you could just deactivate. Great little feature. I love this feature in Juniper. You set something up and say, well, actually, I don't want to use that at the moment, but I don't want to delete it either. You can simply deactivate it, and you just go and grab that, pop it into there, boom, boom, and then there it is, it's inactive. So we'll commit that, and it will become inactive. So I love that feature in Juniper. You can set up maybe a static path, maybe it's a routing protocol, maybe it's a filter, whatever it happens to be. You can set it up and you think, well, I don't want to delete it because maybe I want to use it again later, but I don't want to use it now. You just go and deactivate it. Sometimes you might have to deactivate an interface. You just don't want that connectivity at the moment. You just go and deactivate it and then reactivate it later. So great feature. So that's something that you can do if you wish. And that would kind of have a similar effect. Of course, the configuration will still be there, it'll just be inactive. So your LSP will not be running. If I do a show MPLS static LSP and ingress, there isn't one, so it's gone. So even though the configuration is still there, it is inactive. So that's just another way, I guess, around it. But what I'm going to do is I'm actually going to load that configuration which I saved before, which is this one right here. The only difference, by the way, in the labs between what we did before and what it asks you to do basically all over again is the name of the export policy has changed from CE, what was it before? Basically, what do we call it? Let's go look at it again here. CE export loopback to VR export loopback. That's the only difference. The name of the policy has changed, which makes really absolutely no difference to anything. Okay, so I'm just going to go and load that. Do a load override. I'm going to put it back to where it was. There it is, back to there. And quit. And I will do the same for my other remix. Okay, so there we are. So where we should be at this point, just like wait for those new changes to be applied and protocols to get updated, but we should still have show BGP summary, should still be up. Yep, well there it is up, very good. It's all good. And we should have the same on the other. Yeah, the BGP protocols are up, which is what we want. We should still be receiving the route receive protocol from 192.168.1.2. We should still, oops, should have put BGP in there. Okay, here's what I want. Yeah. Something going on over there, haven't I? It goes here. That's better. Ooh, okay, we've got a problem. I'll just do that again. Show route receive. C protocol BGP. Thank you. 192.168.1.2 is what I want. That's what I want to get to. So we're still receiving the advertisement, and we should still be receiving the same from the other end. .168.1.1, and there it is. So we're still advertising our direct route, which is a loopback interface on the CEs, and that's all we need to be at. So that's all good. We're all happy. So the next thing we want to do is we want to go and configure our interfaces for MPLS. So let's do that. Just take a look at them, see we haven't got anything configured on there at present, which we will now go and set that up. Set interface. That's not what I want. What I want is set GE 0 dot unit 210 family MPLS, and I want to set up my other one as well. It's that one, GE001, and that's all good. So take a look at that. And that looks good. So we've got that configured on both of those, which is what we want. Now we go to our protocols. MPLS, and we're going to include our interfaces in that. Oops, set command, set interfaces all, set interface FXP0 and disable. Let's take a look at that. Alright, so we've got everything except FXP0 included in our protocols, and we should just commit that, and then we'll take a look at that. Run show MPLS interfaces, and there they are. So we've got both of those, 001, 000 and 001 included. And of course GE004 is not going to be up because it's not included in our protocol. By the way, on your labs you don't see GE004. I don't know why it's not displayed. It's definitely there, but not. I think just the change in the version is that in this version you see the interfaces that are up and the ones that are down, whereas in the previous version you only saw the ones that were up. I think is the difference. Just the difference in the version of the operating system, Genox operating system. Okay, we'll do the same on the other VMX. There's our interfaces. Unit 212 family MPLS. Right, set up the other interface. 1, and that becomes 213. There we are. Let's take a look at that. Family MPLS on 000 unit 212, and the same on 001, which is what we want. Go over to our protocols and include the interfaces. Edit protocol MPLS and put our interfaces in there. All, and we will take out our management FXP0 disable. Let's take a look at that. Okay, there we are. All the interfaces except FXP0. Commit that, and then we'll do a check. Should always do a check after you commit something. So So we're going to do a show MPLS MPLS. Okay, got to put run in front. Ah, all good. Alright, so now we've got that done. We are going to go now into our protocol RSVP, and we're going to set up our interfaces under there. So we have to enable the so we have to include our interfaces in the RSVP protocol. Okay, so unlike MPLS, you don't go and configure the RSVP protocol under the interfaces hierarchy. You simply include the interfaces in the RSVP protocol. Let's do the next one first. We could go set interfaces all, but let's just follow the labs and put them in. Yeah, it's the unit number, so you put dot interface name followed by the unit number. In this case, it is going to be 210. And I will go and include 001. Let's take a look at that. So there they are. That's all good. We'll commit that. Do the same for the other device. It's going to be 212. Let's take a look at that. Looking good. Commit that. All right. So that's good. Now we're going to dive back into protocols MPLS and we'll set up our label switch path. It's just going to be a whole lot easier than the static one that we created. Right, now one of the first things we are going to do here is we're going to set the no CSPF parameter. And the reason for doing that is because the default behavior of this RSVP label distribution protocol, the default behavior for any label switch path that it creates is that it will use constrain shortest path first. It will use that algorithm to calculate the LSP or to build the LSP, and that is the default behavior. And it is actually would be an unusual situation where you would not want to use CFPF because it is so beneficial to use it. However, in this lab, we're turning it off because there is a very specific aspect of RSVP signal paths that we want you to see, and it's called the explicit route object. We really want you to see how that works, because if you don't understand or you don't see that explicit route object and see how it works, then this whole constraint shortest path first thing will make no sense at all. So I just want to see that with CSPF turned off. We'll create a manually defined explicit route object, just so you can see what that does, because we really want to see that working. Okay, next thing we are going to do is create our label switch path right here. So we're going to go set label switch path. This is from this one's going from P1 to PE2, so we're going to give it that name, PE1 to PE2, and this is the first path we're going to create. I might give you a clue that there's going to be another one. This is going to 192.168.1.2, which is of course the loopback address of PE2. Alright, there we are. Let's take a look at that. So there we are, level switch path, PE1 to PE2 -1, and we have got the address there of our egress router's loopback. Okay, so we're going to commit and quit. And the next thing we're going to do is just show MPLS. Let's do a show MPLS LSP. And we have one. We have a path. There it is. Okay, so one of the things you might notice straight away is we didn't give it a label value. We didn't give it a next hop. But we really basically just said, okay, create a path to here. That was it. And RSVP has gone and basically built that path for us and created the path. So there it is. It has already figured out what is the next hop. It has already figured out what the label values are going to be. So we'll take a look at those shortly. And there's our path. So if we do a, let's just do this, show, let's do the same again, LSP ingress. And let's do an extensive, we'll do an extensive. Alright, if you do that, what we've seen here is, here we have a label switch path. It's going to be using predominant hop popping, as it says there. And if we just go through and take a look at it, the state is up. We have this thing called a RRO, which stands for Record Route Object. And this is very interesting because what it tells us is all of the different hops through which our path will be traveling and the labels that have been assigned. So RSVP has figured out the path and also assigned the labels for us. So there is no static label assignment here. That is all done by RSVP. Okay, so that is one of the great advantages of using a signaling protocol. There it is, there's our record route, goes through, it tells us all the hops along the way, etc. So there it is. Okay, that was easy, very easy. Let's do the same on the other device. Protocols and PLS. And we are going to set our label switch path. We're going to have it go the other way this time. Set label switch path. This one is going from PE2 to PE1. Of course, the name doesn't do anything, by the way. It's just a name. You probably figured that out already. What does make a difference is the address after 2. which is 192.168.1.1, which is the address of our egress router. I need to put the let's see. There we are. Just make sure the fast path first in there. Just take a look at that. Alright, that's what we want. Looking good. Okay, let's take a look at, let's go back onto VMX1. And now we see two paths. Okay, so on my VMX1, I'm looking at two paths now. One is VMX1 is the ingress router, and the other VMX1 is the egress router. So we've got the names of them there. Right, so that has all been picked up and displayed very nicely through the RSVP protocol. Okay, so there we have our two paths all looking good. And we already had a look at the route, the record route information that is in there, so we can see the exact path that our LSP is taking. So there it is again, just have a look at that. There's our record route. So if we take a look at what that path is, it's going from 172.2.2.10.2 to a 1.2 to a 6.2 and across to 172.2.2.12. And if you look at that, path, take a look at our lab diagram here. We can see that that is taking the path across the top here. So it goes up through P1, P2, P3, and then onto P2. Okay, so it's taken the top path. We didn't tell it to take the top path. RSVP just said that it was going to take, figured that out for itself basically. Let's do the same down here. We'll take a look at this one. And we'll see which way it is going. Oops, down here. We want to see into there. Let's be ingress and extensive. Alright, so this is looking at the other device, and here's our record route object. And this one is going back across the same path, but of course in reverse. Okay, so it is also taking the top. See that the next hops are being calculated, the labels have been assigned, RSVP has done all of that. Okay, so there's our paths. We should have connectivity there. Let's do take a look at our routes. Let's do a show route to 192.168.11.2, which is the loopback address of the CE at the other end. And we do in fact have a BGP route to that, and the BGP route is going to use level switch path P1 to P2. Okay, that's the path we are using. Alright, and of course we should see same on the other device. So we're going to show route to 192.168.11.1. We will see the routes going the other way, and this time it's using the path from PE2 to PE1. Okay, so it's using our level switch path, which means we should have connectivity. We should be able to actually ping, shouldn't we, that remote device. So let's give that a go. Ping 192.168.11.2. We're going to ping it from the other CE to specify a source address, which is 192.168.11.1, and we need to specify the routing instance in which that source address resides, which is CE 1-1. That's it there. Okay, so that should work, which it does. So there we are. We're now using our RSVP signal path to send traffic from one side to the other. We've sent 8 packets, so we should be able to check our stats on that path and see those 8 packets. And there they are. There's our 8 packets. Okay, so so we can verify that that particular ping went via our label switch path right there, because there's our 8 packets that we sent, and there's our 8 packets sitting there in our stats. Okay, if we check the other router, we'd also see 8 packets, because of course we would see the return on that. I'll just do that. There they are. That was easy. Alright, there's our 8 packets coming back. Alright, so what we've done is we have set up an RSVP signal path. We have done it without using the CSPF algorithm. As I said, that is unusual, because normally by default we would use it. We have to actually manually disable it. And now what we're going to do is we're going to set up this thing called an explicit route object. Now this is the point that we really kind of want to get to, because what this explicit route object allows us to do is to specify a path through which the LSP must travel. So we're going to say, we don't just want you to go anywhere you like, we're going to give you the path. We're going to specify a path through which this LSP must traverse. And this really is where the traffic engineering part begins, right here with this explicit route object. Okay, so let's get in and do this. We're going to go under the edit protocols MPLS to define this explicit route object. And we're going to set this path. Now, one 172.2.2.2xy.2. Let's have a look at that as to where we are going. So where we want to go with this is we want to send it actually down through P4 is where we're going with that. 5.3, let's check that one. 5.3 is over there. I was checking the labs just to see what path we want to send this on, and it's going 172.2.2.1.2. Let's have a look at it. 2.1.1. So we're going to send that down through the bottom PE, down through PE4. We're going to set up a loose through 191.168.5.3. Okay, so if we take a look at what we want to achieve here, here's our diagram. What we want to do is we want to set this up here so that the path goes from P1 down to here, down to this point, 172.22.211.2. So it's going to go through there. We're now saying we're going to set up a loose, what's called a loose hop, basically up through here. So we're going to say you have to go there, but we want you to go to there as well. But we're not going to really say how to get from P4 to P3. We don't really mind which way you go. Okay, we're going to let the IGP make up its mind about what the best sort of path through there is. But we want to go to there, we want to go to there, and then of course we need to get to our egress, which is over there at P2. So that's kind of where we're going with this. All right, so let's do that. Set path. We're going to call it my ERO. We could have called it anything, but I'm going to call it that. Oops. We are going to say you're going to go through 172.22.211.2. So you have to go through there. Strict means that if we do a strict path, that means every hop between our current location and the strict path has to be specified. We can't just leave anything out. We've got to specify every hop in between. Well, there's only one hop between us and there, so that's quite easy to say you have to go directly to there. And then the other one we're going to do is we're going to set up this loose path. And we're going to set it up through 192.168.5.3. It's loose. Okay, so we've got that. Let's take a look at it. So there's the path, my ERO. We could have called it anything. I don't have to call it my ERO. Normally, you would give it a descriptive name that actually represented what the path actually was. But now what we've done, we've created that. And the next thing to do is we're going to apply the path. Okay, we're going to apply the path to our label switch path. So let's do that. Set label switch path, and this is the P1 to PE2-1. We're going to set up a primary path. Now the reason we're setting up a primary path is because it's possible to set up a secondary path or some another path. So we're going to set up a primary path. Okay, there we are. And this is my ERO. Okay. So I'm going to pick it up. My ERO. There we go. Let's show that. And there it is. So there is my primary path. So I've got the path, my ERO specified. I've applied it into the label switch path right there. And we shall do a commit and quit. It's all good. Now we'll take a look at the path. Make sure that this is up. And it is up, so there's our path. We're using the my ERO as our active path. That's what we want. And if we take a look at the an extensive on that, or even a detail, do a detail. of the lab. So there's a detail. What we are seeing is that we're using the myERO as the primary part, northern hot popping, which is normal. And let's take a look at our receive route this time. Okay, so this time we are going down through 172.221.2. Sorry, 211.2. We're then going across to 172.22201.1. Where is that? That's actually up onto P1, but then it goes across to P2. Then across to P3, and finally 172.22212.1. It's actually coming in on GE000 on PE2. Okay, so we're actually sending it out the bottom through to P4. It then bounces straight up to the top and then goes across the top over onto P2. Okay, so what we've done, essentially what we've done with our explicit route object is we have told it you have to go to this point and then you have to go through this other point. Okay, so the points we've told it has to go through is the interface on P4 that is connected to PE1 and the loopback interface on P3. We've given it those 2 points that it must traverse, and this is the path that it has ended up taking. Okay, so that's the purpose of an ERO, is to control the path through which the LSP traverses. And of course, we would do the same thing on our other device. So let's do that. Let's take a look at what we've got in there. There's our lever switch path. So we are going to set a path. We are going to call this path myERO, just like we did before. Like I said, you could have called it anything. We are going to set up a strict on this. So we want to send it down to P6 through 172.22213. So I'm just going to go to 172.22213.2, which is the other end of that link, and strict. That's that one. And then we're going to give it a loose. And we're going to give it the same loose as what we gave it last time. 92.168.5.3 loose. So there it is. We've got a strict and a loose parameters in our path. Now we're going to apply that to our label switch path. There it is there, and primary. And this is going to be my ERO. Let's take a look at that. Okay, so we have applied that, and commit and quit. Now we can take a look at where that path has gone. Oops. Oh, LSP. Ingress, and we'll take a look at the detail of that. So we've got the primary path is the my ERO. As we go down, we will see this path actually up. Let's try that again. Oh, the state is down. That's not good, is it? Let's take a look at why that's down. 192.168.5.3, 192.168.5.3 was my loose. 172.22.213.2, 213.2, that looks right. That is up. I'll just do a show BGP in case it's having a problem. Should be right. Okay. Yeah, we've got a little problem with that. It is down, and I don't know why it's down at this stage. I have to have a bit of a look and find out what is happening there. I see the session has been preempted quite a few times. So hasn't been able to come up actually. So there's an issue. I don't know what it is, but I can see we've got a record route here this time. It's going through 172.22.212. So I'm just going. Where's that? That's actually the other one, I think. Let's have a look at it again. Yeah, there it goes. 172.22.213. Now it's up. So it goes to 213, then it goes up to 207, which is straight across the link between P6 and P3. So it's basically going down to P6, straight up the link between P6 and P3, and then it's going across the top all the way over to GE000 on PE1. So it goes there. So it took a little bit of time to come up that. There it is. It's up. Alright. Yep, there it is. It's up. Okay, so there we are. So essentially, left to its own devices, the paths traverse right across the top to P1, P2, and P3. But using the ERO, we force them to go down through P6, which they do. And you can verify that looking at the record route object, and you can verify that has actually gone down through the path that we've told to go through, and then it's found its own way over to the egress after that. Okay, so that is really what I really wanted to get to have a look at with the explicit route object. The other thing that we are going to be doing in this lab is configuring up our LDP as our label distribution protocol. which is very similar to setting up RSVP. We're going to go here, we're going to deactivate RSVP, we're going to then configure up LDP, take a look at that, and then we're going to go on and activate RSVP again, and we'll just see what happens when we've got both of them going, and we will discover that in fact RSVP is the preferred signaling protocol over LDP, and its LSPs actually take preference over the LDP signaled LSPs. Right, so what we might do before we do that, let's take a short break, and we'll come back and configure up LDP, have a look at that, and that will do us for the day as far as where basically our lesson goes. I'm going to let you guys get in and do your labs after that. Okay, so we'll take a break and then we'll take a look at LDP.